Okay, lots to tell you guys. So while you're getting your notes out, be listening, please. So let's talk about the test. This class had the highest average, okay, 87%. No 100% though. That was kind of strange to me. You guys had 10, well, I'll get to that. So you guys had the highest percent. That's a very high test average. Excellent job, guys. I broke it down even more for you so you can see the number of everything. So you guys are the red, your period 3. So you guys had 10 A's, 11 B's, 2 C's, no D's, and no F's. So this class had 0 D's or F's on the test. That is phenomenal, okay? So all of you fell from the C up category, and then you can see the total throughout the day. That's a very lopsided curve in your favor, right? We'd rather see 51 up here than 51 down here. So you guys should be very proud of yourselves of how you did on your first test. So what I want you guys to know is this. You now have been through one full cycle of this class, of like starting a unit with notes and having quizzes and homework checks. You saw how I do a test review, and now you experienced your first test and you were all successful. So that's just going to repeat itself throughout the year, right? Now we're starting a new section of notes and all of that stuff, and the cycle just repeats. So think about yourself personally. Austin, pay attention, please. You're distracting me. What was I saying? Think about yourself personally, how you did on the test. If you were up in this range, I even have people that get 95s and are not happy with that. They're like, what did I do wrong? I need to do better. I want 100 next time, whatever. Or anywhere else that you may be. If you are happy with how you did, think about, what do I need to continue doing? What made me successful? Was it I made sure I completed all my homework? I paid attention in class and wasn't distracted doing other things? Whatever it may be. And if you were on the other end, like you were at a C and you really wanted something higher, think about what you could do to change. Okay, I know I wasn't finishing my homework. I was copying the key. Because it's really nice how she gives us the key to every homework assignment, because I could just copy them. Okay, go ahead, but that's only 10% of your grade. Whatever. But think about what you can do to now change. Because you know how I do things. I'm very regimented. You know it's going to be like this going forward. So think about what you need to adjust or continue doing. Okay, so really good job. There's 2 tests every quarter, so we'll have another one this quarter. The next test will start with 1.6 and go to the end. I don't remember what it ends at. But 1.6 is your final notes that you have in your binder right now. We do have the new ones ready to go. They are a hole punch, thank you, Lord, and they are numbered. The pages are numbered. So that'll be a benefit going forward. Don't throw away sections 1.1 to 1.5. You may need them. When we get to Unit 2, the next unit, I'll say if you want to clean out your binder of Unit 1 stuff, go ahead. But right now, keep all Unit 1 stuff in your binder, okay? Next thing I want to tell you is when you look on Canvas, I use Canvas quite a bit. I'm recording my lessons every day. I am uploading notes and keys to the homework every day. We now have, and I know you guys can't see, so try and look over here. We now have a second module. I always put the newest one at the top. So the first one we did that we just took a test on was test number 1, quarter 1. That's going to be moved down. Now we're in test number 2, quarter 1, okay? And you can see the sections there. But I'm editing this all the time. But just know, anytime you go on Canvas and you're like, because let me take you out of student mode, student view, so what I see, I have all of our modules in here for the whole year. I'm sure that shocks you with the way I am. But I don't have them published. So, as we go through the year, you're going to have tons of modules. And I always, even by the end of the year, I always have students saying, I don't know how to find your stuff. Remember, I always am going to put the most current stuff at the top. So when you go into modules, go into the very top one. That's where the current stuff is. But I leave all the other stuff there for you in case you need to go back and see something, okay? So just keep that in mind. I think I've shown you this square root curve chart before. This is what I use on all tests. You could always look at this. You can Google it. It's a common square root curve that AP math teachers use. So if you wanted to see what your actual raw score was before I gave you the curve, you could look at this. So like, for example, if you got an 89, or no, let's use something more drastic. If you have a 70 in the grade book, you actually got a 49 on the test, okay? Why do I give you such a generous curve? For the same reason that I teach you guys, I'm preparing you for the AP test. I try to make this class as close to what you are going to expect that day. May 13th, 2025 is going to be here before we know it. And when you walk in, you're not going to be like, I'm not sure how to write my notation on here. I don't know what this question is asking. I am teaching you to a test. I grade you like that test. And the test, the AP test, is a very generous curve as well that's similar to this one. So that's why I do that for you all year, okay? So don't let that discourage you. It's normal, okay? These tests are hard. We learn a lot in this class, and you're expected to know a lot. So there is a generous curve, okay? But you guys are learning a lot, for sure, with getting all A's, B's, and C's. Okay, any questions before we start today's stuff? Okay, so, sorry, I have 2 dislocated discs in my back, and I'm always in a lot of pain, so you might see me like squirming a little bit because my back hurts all the time. All right, so here we go. What was I going to say? Something else I thought. It'll come to me. All right, so what we're talking about today is end behavior. And a lot of what we talk about today, a lot of it is review of stuff we've done in here already and of what you might have been taught in Algebra 2. Again, when I bring up Algebra 2, I'm not bringing it up like, oh, you should already know this. I'm going to skip over it. For example, factoring. I am just saying it's probably going to be a concept that's not foreign to you. And just to understand what end behavior is, end behavior has to do with what the arrows are doing on a graph, the ends of the graph. What is the behavior of the graph after we leave this window? We know what that means. As we go to the right, we also go up. As we go down, we're also going left. That's end behavior. It's stuff we've already been talking about. What's wrong, Zach? Okay, not a bug? Okay. Looked like the way he was doing it, there was a bug. I'm freaked out about bugs. Okay, so in a minute, we're going to talk about 2 things that are tied together with end behavior, and I'm just going to underline it. It's degree and the leading term of a polynomial function. Those 2 things are what a lot of this lesson is about and determining what end behavior is. We can go 2 ways. We can look at a graph and we can tell what we can look at the end behavior of a graph and tell the degree and what the leading coefficient is, or vice versa. We can see the degree and the leading coefficient and tell what the end behavior is going to be. So we'll get to that in a minute. But right now, let's talk about some of the language and the notation we're going to be using. So when you hear these words or see these words, inputs increase without bound. Let's first talk about inputs. Anybody remember what inputs are? Come on, you can just say it out loud. X. Yep. Inputs are your X values. Outputs are your Y's. Okay? So participate, please. I don't want to call on people. So inputs are your X values. Outputs are your Y values. So there's so many different ways to say everything in this class that we have to always be practicing and make sure if they throw it to us as inputs versus X's versus this, that, zeros, roots, solutions, we know what they mean. That's why I keep repeating this stuff. Inputs increase without bound. So we know that that's talking about X's, and increase, getting bigger, right? We know increase. And this without bound means it goes towards infinity or negative infinity. I think of the word bound like boundary, like there's no boundary holding me in. I can keep on going up or down or left or right forever without bound, no boundary, okay? So how could we write this another way? This would be the X values are moving towards, since it's increasing without bounds, that means the X values are moving towards infinity. Now you could put positive infinity, but we don't have to say or write the word positive in front of the word infinity. Just like if I say the number 5, none of you are like, does she mean positive or negative 5? If I say 5, you know I mean positive 5. If it's negative, we say the word negative. So inputs decrease without bound. That would be the X values are moving towards negative infinity. Okay? So decrease would be going down or to the left, and increase would be up and to the right. So keep on going. Outputs would be talking about the y values. So if you hear the outputs increase without bound, that would mean the y values are moving towards. Increase would be positive infinity, or just infinity. And lastly, outputs decrease, so y values are moving towards negative infinity. Let's break that down further. Oh wait, one more thing I have to tell you here. There's a new symbol notation that we need to learn. And instead of saying moving towards, write this over here. We use the word approaches, and the symbol for that is an arrow pointing to the right. Okay, and you'll see us use that more in a second. If I am approaching Lily, I'm moving towards her. So if I get up and start walking towards her, I'm moving towards her. You could also say I'm approaching her. Okay, so the word is going to be approaches. Hold that thought. We'll get to it more in a second. Okay, but that's going to be important. All right. So down here, let's just take it a step further. If the inputs increase without bound, what direction on the coordinate plane are we moving? And your choices are up, down, left, and right. So if the inputs are increasing, what direction are we going in? Up, down, left, or right? Right, right? X values. If it's inputs, it's X values. If you're talking about an input, you have left or right. That's the only way X's go, right? Left or right. So increase would be to the right, okay? The inputs decrease would be which direction? Left. Thank you, Jocelyn. Outputs increase. Where would that go? Up. And outputs decrease would be down, okay? So translating into different words, okay? Understanding directions with those words, okay? Move on to the next page. Next page. All right, on the next page, end behavior describes what the y values are doing as the x values increase or decrease without bound. And I think this next part of the notes is a little confusing. What I want you to take from this little box here is that if we're talking about a graph, we will have two arrows, right? You will have left end behavior and right end behavior. So we talk about the left-hand side and we talk about the right-hand side. They have their own little thing going on, okay? And so looking at this graph, let's use this actual graph to kind of answer these questions. As the input values increase without bound, what are the output values doing? So input values increasing mean we're going to the right. What are the y values doing? They're going which way? Up, which means they are increasing without, I'm using lots of abbreviations here. I have to do this lesson 6 times today. So that means increasing without bound, meaning up, right? Another way of saying going up. And as the input values decrease, we know that that means left. As on this specific graph, as the x values go to the left, the y values are decreasing without bound. So remember, and that just means down. So lots of different ways of saying the same thing. Understand all the different ways you could say it. And remember, without bound in any direction simply means towards infinity or negative infinity. There's nothing that's going to stop you. And we know that. We talk about this in this class all the time. We say, we only are looking at this window, right? But we know because of those arrows that we're going to keep going up and to the right, and we're going to keep going down and to the left. We're just putting more proper language to it now, okay? So what we're going to do right now is learn the varsity math method of saying end statement, end behavior, and that's this box here, okay? This is called limit notation. Limit notation. A limit represents the numeric value the outputs are approaching as the inputs approach a certain value, okay? And this is new to pre-calc. You didn't do this in Algebra 2, but this is something that's a huge concept in calculus and in this class, and we're going to use this other times as well. And it's on the AP exam and an FRQ, and it's worth 2 points. And I can tell you I graded thousands of tests this summer, and pretty much everyone got those 2 points. So I don't want you to be intimidated by this. It looks a little weird. It's not hard at all, okay? So to teach it to you, I'm going to, we're going to write the limit statements for this particular graph, okay? So here's how we do it. So this graph is called g of x. How do I know? I read the directions, okay? We start by writing the word limit as L-I-M. That means limit, okay? And you'll see me write like a cursive L. You could totally write it like a capital L. You can see how they wrote it as a lowercase l. It doesn't matter. L-I-M, however you want to write it, okay? But that's how I write mine. The limit of what? The graph. So the limit of the graph, this one happens to be called g of x. So I'm going to use the proper name. Just like I don't call Lily Evan. I call her Lily because that's her name. We call this graph g of x because that's its name, okay? The limit of g of x as x, there's that notation I taught you, approaches. Now we have to talk about two different end behaviors, this one and this one. Let's do the left end behavior first. As x approaches negative infinity, as I go to the left, put equals, what are the y values doing? They're going down. What do we call down? Negative infinity. So what we just said, let me say it. The limit of g of x as x approaches negative infinity equals negative infinity. That means as I go to the left, I'm also going down. Left and down, okay? Let's do our right-sided, I should say. Sorry, I'm just squeezing this in. If I could make my own notes, I would, because I don't like how she does things all the time, so you notice like constantly changing things. That's for your benefit. The limit of g of x as x approaches positive infinity. So as x goes to the right, what are the y values doing? They're going up. What do we call that? Infinity. That is the way we do end behavior in varsity math, okay? Limit notation. And we'll practice it a bunch. Do not stress about it if you're still not catching on. I promise you will by the end of the lesson. And understand there's always two. There's two arrows. We have two statements. And we have two arrows, so there's two statements. And it doesn't technically matter which one goes first. The order that you write them in doesn't matter. I personally like to put the left first because that's how I read my graph. And that way I don't mix them up. So we read a graph left to right, so I like to put my end behavior from negative to positive. But it won't always be written like that. Okay? Keep on going. Take a break from end behavior. We're going to take a break from limit notation, and I'm going to talk about what I started to talk about at the beginning of class, which was how do we tell end behavior by looking at a graph? Two things, degree and leading coefficient. So that's what we're going to talk about now. This is where you might be like, I feel like I've heard this before, especially students that had me last year. This is a big concept, and I use a lot of the same language right here. So let me start with that. So there's two things. So we're going to be able to look at these graphs and tell some information, okay? We're going to be able to tell if the degree is even or odd. And if you remember, degree is denoted by the letter n, okay? And I'll come back to that in a second. And the leading coefficient. The leading coefficient, what we're looking at with the leading coefficient is if it's positive or negative. The leading coefficient is denoted by this notation. Let me remind you, a week ago, whatever, when we started talking about polynomials, we would see this. And then there was a bunch of stuff after it. This was your degree. Remember, degree is your biggest exponent. Just the biggest number up in the sky. That's degree. We should know that word. I told you it was going to come up a lot. And leading coefficient is that number that's in front. Is it positive or negative? So what we're going to look at in all four graphs is the degree and the coefficient sign. Now, I don't know why these notes don't have degree written as one of the options, so go ahead and do this with me. This is going to be a great page for you to go back to in your notes in the future if you're confused about end behavior. All four possibilities are going to be right here. Okay, so let's look at the first two graphs here and here, okay? What I want you guys to notice is that in both of these graphs, your end behavior goes in opposite directions, right? Opposite directions. That means your degree, your n, is odd. And what's so helpful is that the word opposite and odd both start with O. So if you see opposite end behavior, you know your degree is going to be 1, 3, 5, 7, any odd number, okay? The harder part, and so if you are like, I remember this stuff, listen to this, because every year students get confused by this. How to tell the coefficient sign is really simple. All you have to think about is the most common odd degreed graph that you all know. The one you've worked with the longest. What's the type of graph you guys have graphed longer than any other type of graph? Lines. Okay? If you have a line that goes like this, well, first of all, you would know that that's a degree 1. Lines are degree 1. If your line has end behavior like this, where it starts down, ends up, right? Left is going down, right is going up. What is your slope? Is your slope positive or negative? Positive. Same goes for all end behavior that starts down and ends up. If you're starting down and ending up, your coefficient is going to be positive. Okay? And opposite would be for this one, right? So this would be a negative slope. The number in front of your x is called mx plus b, right? M, but who cares what you call it? It's the number in front of the x to the first power is negative anytime we fall left to right. So that would be negative. So anytime we're dealing with opposite end behavior, think of a line. In between the arrows, different stuff can happen, right? But you can see that my end behavior matches that of a line with a positive slope and a line with a negative slope, okay? That's the harder one. So if you think any of this is hard, if you don't think any of this is hard, this is going to be really easy, okay? So these have same end behavior. See how they go up, up, or down, down. That is even. So your degree would be 2, 4, 6, 8, any even number, anytime your end behavior is the same direction. Really easy to know these as well. Think about the most common even degreed graph you've ever worked with. What is it? Yeah, 2, right? A parabola. We have that parabola or we have that parabola. Look at the end behavior. Up, up, or down, down, right? So how do you know what, and again, it doesn't matter what's going on between it. All we're talking about is the end behavior. So on a parabola, or whether there's a whole bunch of stuff going on in between it, if the end behavior is going up, up, that is like a positive x to the second power, right? Positive people smile. Positive people smile. So this is a smiling person, they must be positive. And a negative person frowns. Okay? So in a minute, we will practice some of those, but this is your go-to if you need to study that or whatever. Just know lines for opposite, parabolas for even. No matter what's happening in between the arrows, all the other stuff is the same when we're talking about end behavior. Okay? Now we're going to put it all together in our final example. Last example, and then we'll do our homework together and be done. And you can forget about me for the weekend. Is example, why does it say example 1? Is this our first example? Oh, okay. All right, so we're going to pull out a bunch of information here and sketch a graph. Guys, anytime the word sketch is there, it doesn't have to be perfect, okay? And I'll show you what I mean. So in this case, our n is your degree, that would be 3, which is an odd number, okay? Our a sub n is -1, right? That's the number in front. That's your leading coefficient, and that is negative. So now let's do our end statements. So stop and think. Odd, I think of a line. And if my slope is negative, it's going to go like this. So the middle part between the arrows is going to be different for every odd degree, but the end behavior will be the same. So as our x approaches, and be careful because you got to look really closely, sometimes that negative symbol almost runs into the arrow. So look at the difference between negative infinity and positive infinity. As we go to the left, we're going up. That's an infinity symbol. And as we go to the right, we're going down, right? Bringing back some old stuff, always reviewing. How many turning points does this guy have? Good, Jocelyn. Right? N minus 1. So we're going to sketch a graph. We don't know the zeros. We don't know where the turning points are, but we're going to just sketch a graph. So everyone's could look a little bit different, but what we should all have in common is that we start up and we end down, right? Start up and end down, and we turn twice. So for example, maybe I'll start here, turn around wherever you want to, doesn't matter. There's a great example. There's 1, 2 turning points. You can see my end behavior, okay? So if the degree isn't 1, it's not going to be straight. You're going to have those turning points in it. But you can see that the end behavior matches a line, okay, because it's odd. All right, look at the next one. Our degree is 4, which is even. What's our leading coefficient? 1, which of course is positive. So even end behavior, that's going to be same. So we are either going to be up, up, or down, down. Since it's positive, we're going up, up. Positive people smile, okay? Positive people smile. So whether we go to the left or the right, we're going towards positive infinity, right? Up, up. How many turning points? Degree minus 1. Degree 4, subtract 1. This was a degree 3, you subtracted 1. Okay? So again, where you, these tend to look like W's. We've seen a few of them. All right? So I'm going to make mine look really funny. You can make it look like a regular old W. I'm going to make mine look funny just on purpose. Notice I'm ending up, up. There's 1, 2, 3 turning points. I made it a little different last period. You can see. We don't know where the turning points are. We're just sketching a graph. That's what I meant by it doesn't have to be perfect. And we'll do it again in the homework in a second. How are we feeling? Doing okay? Okay, let's put it together and the homework together. Okay. Find practice set 1. This is A16. And I'm going to do it with you. Should it be 7? Tell me, Jocelyn. But I told you guys to change it, didn't I? It said A16, but I told everyone to change it to A15. Yeah. The test review is A15. Yeah. All right, guys. Oh, I'm sorry. Sorry. All right, so she throws in some oldies in here, zeros and multiplicities, so reviewing that. We didn't really do a ton with it before, so I'm glad it's here again. Okay, identifying zeros, guys, those are, first you have to factor. Thank you very much. It's already factored for us. We don't have to factor. And then you set your factors equal to 0 and solve, okay? You do not have to show that work. I'm going to show the work just this time in case you need it, but you do not have to show the work to me. So x squared equals 0 and x plus 3 equals 0. Solve. So whenever you have x squared, we would take the square root of both sides, right? And we would have a plus or a minus, but not with 0. You can't have a minus 0. It's the exception to the rule. So we would have an answer of 0, but how many of them do we have? 2. So remember, if you have a power on something, it's how many you have. So that would be a multiplicity of 2. And then this would be x equals negative 3 with a multiplicity of 1. I want to remind you what multiplicity does for our graph. It tells you if you bounce or you cross. Anytime you have even multiplicity, we bounce. Odd, we cross. We'll come back to why we talked about that in a second. Here's where we're going to write out our limit statements. Okay? So the limit of who? F of x. As x approaches, now remember, you can do negative or positive first. I like to do negative first. Am I making up f of x? No. I went back up and looked at the directions and looked at the actual function. That's the name of it. So that's why I used f of x. Okay? So how do we tell our end behavior when it's written in factored form? The ones we had in our notes were in standard form. So it was x to the something, x to the something, x to the something as you went down. But here, we just have to do a little bit of work. We take the first term in each of those and multiply them. Again, you don't have to show that work. X to the second times x to the first is x to the third. So what that means is if I FOILed or distributed x squared and made it be in standard form, which we're not going to do, this would be the first term. So it's really just doing like the first step of the distributive property to get the first term. So since it's an odd degree, we know it's opposite, and it's positive in front, so like a positive slope, it would go like this. So as we go to the left, we're going down. As we go to the right, we're going up. Good. Now we're going to sketch the graph. Sketch again. In this example, though, unlike the notes, we do have zeros. Let's put those on the graph. Remember, zeros are your x-intercepts. We have an x-intercept at 0 and at negative 3. We also know that we're going to start down and up. And we know one more thing. We know that at 0 we're going to bounce, and at negative 3 we're going to cross. What we don't know, and can change from person to person, is where you turn around. Okay, you can go high up or low, it doesn't matter. Okay, so for example, I know I'm going to start down, and when I get to negative 3, I'm going to cross. So I'm just going to go right through it. So I'm going to cross through it. Okay. Now what happens in between these two zeros is up to you. You can go way up high, you can turn right now, it's up to you. So just turn around at whatever point you want and head towards your next 0. And then ask yourself, what do I do when I get to this 0? I bounce, also known as touch and turn. So I touch it and I turn around. And you can see my end behavior is just like a line with a positive slope. It's got those turning points in there. 2, to be exact, right? This could have gone way up higher or lower. We're not worrying about where the actual turning point is. Okay? All right, let's do another one. 1, 2, 3 x's, so we have 3 zeros. We have x equals negative 2, x equals 1, x equals 3. The order you write them in doesn't matter, okay? I'm just setting each of my x's equal to 0 and solving. I only have one of each, right? There's an exponent of 1 on each of those. No. So this is all multiplicity of 1, which means we will cross at all 3 zeros when we get to the graph. Odd multiplicity, we cross. Let's make our limit statements. The limit of who? G of x. As x approaches, again, I like to do my left end behavior first, so that's negative infinity. Got to do a little bit of work here to figure out what the first term is. Because remember, in a polynomial, the way we had all these written, like, of course I don't see an example. Oh, the way we were just, what we were just doing, when we look at the end behavior, all we care about is the first term, okay? We don't care about the rest of it. So that's why I'm only worrying about what my first term would be. I'm going to multiply negative times x times x times x. So there's a negative in front times an x times an x times an x. That would be negative x to the third. That would be like a line. Anytime I see an odd number, I go line. It's like a line with a negative slope. So I'm picturing this in my head. That's not the graph, but that's the end behavior. Okay? So that means as I go to the left, where am I going? Up, right? Going up. That's positive infinity. And as I go to the right, I'm going down. Do you see that, Evan? It'll click. It will. You're going to go, oh, I see it. It's okay if you're not there yet. All right, sketching the graph. Let's go ahead and put our zeros on there. We have a 0 at -2, at 1, at 3. Right? Those are my 3 zeros. I'm going to cross at all of them, and I'm starting up. What I don't know is my turning points. That's okay. So I'm going to start up, cross, and we always graph left to right, okay? That's why I'm always starting to the left. And then I'm going to turn around somewhere. Pick where you want to turn around. I'm being obnoxious for a reason. Turn around, cross again. I'll be obnoxious again. Look at my end behavior. Evan, look. As x goes towards, that's to the left. As I go to the left, what are my y values doing? They're going up, right? That's positive infinity. That's up. As my x values go towards positive infinity, which is to the right, my y values are going down. That's negative infinity, okay? How'd we do with that, guys? Okay? All right, that was 1 through 6. We only have to go to 10. And it looks like a lot on this next page. It's just that it's really spread out, okay? Like, these two whole boxes are just doing the limit statements, okay? So let's set them up. Let's just go ahead and set them up. This is state the end behavior for decreasing, so that's to the left or towards negative infinity. This one's to increasing to the right or positive infinity. So I'm going to go ahead and set these up. So this is the limit of f of x as x approaches negative infinity. And I'm just going to set them all up. So you do the same thing. Limit of g of x. And then h of x. And we'll come back and fill it in a second. So number 7 is the left end behavior for all 3 graphs. And then I'm going to write the right end behavior for all 3 graphs. It does take longer to write these than it does to figure out the answer, but it's really important to understand the notation. A lot of you got a point off on your test yesterday because your FRQ didn't have a bracket. I mean, your range didn't have a bracket. A lot of you put a parentheses on your negative 12.4 or whatever it was. Have to put a bracket. You lost a point. Have to be good with your notation. That's half the battle in this class. Okay, so let's look at f of x. Let's look at f of x. That's this graph right here. As we go to the left with our x's, our y's are going down, which is negative infinity. What's it doing on the right-hand side? It's going up. That's positive infinity. In g of x, both sides are going down. To the left to negative infinity, to the right, negative infinity. And then h of x, down on the left, right, up on the right. Are we getting it? Not hard, but new. So we get scared of new sometimes. All right. For this next section, for each of the graphs, we're going to state what the zeros are, and we're going to state if the multiplicity is even or odd. Okay, just even or odd. And I'll explain what I mean. So let's list our x-intercepts for f of x. There's 2 of them, right? Oh, there's 3 of them. 1, 2, 3. 3 x's. Put them in any order you want. Negative 3, 1, and 2. Those are my x-intercepts for f of x. All 3 of them do what? How do they interact with the x-axis? They all cross, right? We cross, we cross, we cross. That means our multiplicity is what? Even or odd? Yeah. Because they cross. Odd is cross. All right, g of x has how many zeros? How many zeros does it have, guys? 2. 2 x-intercepts. Put them in any order. Let's see how the graph interacts with the x-axis at those zeros. Cross, cross. These are both crosses. So I know my multiplicity here is also odd. Okay? And for space and time's sake, there's 4 different x-intercepts here. Put them in this order. Just trust me. There's -5, -3, 1, and 3. But again, the order doesn't matter. The reason I had you change the order is because there's one single bounce in there. See how we bounce at -3? The other 3 are crosses. So because we bounce at this one, we know it's going to be an even multiplicity. 2, 4, 6. These all cross, so it would be odd. Okay? And last, done, we're done. Degree and leading coefficient. We're going to say even, odd, positive, negative. Notice the notation. N is degree, A sub n is leading coefficient. So f of x is going like this, right? That's my n behavior for f of x. That means my degree is what? Even or odd? Odd means opposite. Opposite. These are going opposite. I'm going to have either a 1, a 3, a 5. Odd. Trying to hurry. Odd. We're going to have odd n behavior because we're going to have an odd degree because the n behavior is going in opposite directions. And since it starts down and goes up, is that positive or negative? Look at g of x. My n behavior goes down, down. That's same, goes in the same direction. Is that even or odd? Even. Down, down means we are negative, right? Negative people are sad. It looks like a frowny face. Negative people are sad. Not necessarily, but you know what I mean. Don't come at me about that. Okay, and then this one is down, up. That's opposite. Our degree would be odd. And just like the other one, that's going to be a positive slope. So the mistake people make, we're done, is they think if it goes down first, that means negative. Think of a line. That is a positive slope. Good job. So much paper.
And then he threw like 2 more touchdowns.
You can, yeah, put it right there. It's fine. Thank you.